Hello, today we're going to start section 3.2, which is multiplying and dividing rational expressions. So far we have learned how to simplify, and then now we're going to learn how to multiply and divide. Multiplying and dividing I think is a little bit easier than adding and subtracting, so that's why we're going to do that first. So many problems require finding products and quotients. So remember, a product is a multiplication problem, a quotient is a division problem. So you can multiply and divide rationals the same way that you would multiply and divide numerical fractions. It's going to work the same way. So just like when you would multiply two number fractions, you would times straight across the numerator and do a times c. And then for the denominator, you do across the bottom and do b times d. Same kind of idea is going to apply here, but we are just going to have polynomials involved now. So if we look at this first product, I have 5 over y times 3 over y cubed. Again, we're just going to multiply straight across so that I get 5 times 3, which is 15. And then on the bottom, y times y cubed is y to the 4th. And that would be your answer. So that was a pretty easy one. They do still want you to do excluded values. That's going to happen really whenever you have variables in the denominator. So on these, since it's just a y and a y cubed, we just can't plug 0 into either of those. Y cannot equal 0 would be your excluded value. Okay, on this one, again, we still just times top to top, but you will notice that they do have some binomials here now. So when I times these, I'm going to do x times x plus 1 on the top, and then on the bottom you'll have x minus 2 times x minus 3. And depending on the problem, sometimes they're actually fine if you just leave it like this and you don't simplify anymore. So you might just even be able to stop right here. If they tell you they want you to simplify it, then you will need to do your distributing and your multiplying, which would give you x squared plus x on the top. And then on the bottom, you would have to FOIL it, which would give you x squared minus 3x minus 2x, which would give a total of a minus 5x. And then negative 2 times negative 3 would be a positive 6. So it just depends on the formatting of the question, if they want it to be in simplified form, or if they just say just to multiply, you could probably even just leave it like this. But with our excluded values, we would want to look at both of these original denominators. For the x minus 2, x can't equal a positive 2, and for x minus 3, x cannot equal a positive 3. So those would be your excluded values. And I'll just put a box around that one. Okay, I think those are the easier ones. I'm going to skip these two next ones because they're really similar, just for the sake of time on this video. Let's get into some that are a little bit more difficult. You'll notice on these ones we have a trinomial here and a binomial on the bottom, and then these ones are just kind of a mix. Sometimes you might be able to actually reduce first before you start multiplying, because if I started multiplying now, I'd have to be doing a lot of FOILing, and then it will make it harder to cancel afterwards or reduce after the fact. So we actually want to reduce or simplify first if we can. So this is where it's going to be really similar to the last lesson, where we want to go through and we want to factor all of the parts and see if anything can cancel. So we have a 3x squared over an x plus 2. On this one, we can't really simplify any of these, so I'm just going to leave it, but let's look at this trinomial. If I think what multiplies to be 2 but adds to be 3, we would get 2 and 1. So I can factor this to be x plus 2, x plus 1, and then we have that x still on the denominator. And here we have a 3x squared. What I'm going to do is I'm going to break up that x squared to be 3 times x, just for a visual here in a second. Because if I write it out this way, I can see a little bit easier that one of those x's from the x squared cancels with this x on the bottom, so we can cancel that. And then we also have this x plus 2 that can now cancel that group with this group right here. And so everything on the bottom canceled, and we have a 3x left in the numerator on this one. And now I need to times it to the x plus 1 from this fraction, because remember, these are still being multiplied. And then if you wanted, you could put it all over a 1. Technically, that would be true. Usually we don't write it though, but now my multiplication is going to be a lot easier since I canceled most of my stuff out here. I would much rather multiply just these two little things than have to multiply all of this and all of this on the bottom. So I end up getting 3x squared plus 3x as my answer. And that's going to be a lot easier if we cancel and reduce first and then do our multiplying rather than multiply and then try and reduce. And then for our excluded values, we look at our original denominators. So for x plus 2, x cannot equal a negative 2. And then if it's just an x cannot equal a 0. So I'll just put both of those there. Okay, let's try another one. Again, I'm going to try and reduce and cancel anything I can first. So thinking of numbers that multiply to be negative 12 but add to be negative 1, we can do negative 4 and positive 3. So this will change to be t minus 4 times t plus 3. And then on the denominator, t plus 1, we can't really do anything, so I'm just going to keep it at t plus 1. And then we have a t plus 1 here in the top, which is nice, and a t plus 3 in the bottom. So we can already kind of see where this is going. I can cancel the t plus 1 since I have one on the top and the bottom, and same with the t plus 3s. So everything canceled except for that t minus 4, which again, you could put a 1 in the denominator, but it's not going to change your answer at all. It'll just make it look messier, so we'll just keep it as a t minus 4. So that one canceled a ton. And then for your excluded values, looking at those original denominators still, for t plus 1, t cannot equal a negative 1. And for t plus 3, you can't have a negative 3. So those would be your excluded values there. Okay, let's look at this one. Again, we're going to go and reduce and factor each part and see what will cancel. For 4x plus 1, there's not a greatest common factor, and we can't really do anything, so it's actually just going to stay 4x plus 1. But for 5x plus 10, we do have a greatest common factor of 5. So if I take that out, I'm left with x plus 2 on the inside. And then move to this numerator, 30x plus 60, we can take out a 30 on that one, which leaves us with x plus 2. That's convenient because those are going to cancel. And then on this one, we can take out a 2, and that leaves us with x minus 1. So our x plus 2's cancel. You can see that. And then we also have these numbers here. You could times the 5 and 2 together. So 5 and 2 would make a 10, and 30 divided by 10 is going to be 3. So we have a 3 left over on there. And then we also have the 4x plus 1. I'm going to put that on the inside here. And then on the bottom, you have an x minus 1. So I'm just going to reiterate, I tried to really emphasize this on the last video. We can't cancel like just the ones here. So this x minus 1 is a group, and it's all or nothing. I have to be able to cancel the entire x minus 1 in order to cancel anything at all. So I can't just cancel the ones, or I can't just cancel the x's. So since these two groups don't match perfectly, we just have to keep them. But we can distribute that 3 through so that we get 12x plus 3 over x minus 1. And that would be your answer. And then for your excluded values, we do have some coefficients here, so it might be easier for you to actually write out the problem and set it equal to 0 rather than do it in your head. But first we would minus the 10 over, we would get 5x equals negative 10, and then divide by 5. So x cannot equal a negative 10/5, which is equal to negative 2. And then for 2x minus 2, if we set that equal to 0, we'll add the 2 over. I'm going to run out of room. 2x equals 2. And if we divide by 2, x cannot equal 1. So our two excluded values would be negative 2 and 1. So remember, when you're doing those excluded values, you always go based off the original denominator, set it equal to 0, and simplify. Some are going to be easier. If it's just your variable plus or minus a number, you can just switch your sign. But if you do have those coefficients, it might be better to just write it out really quick so you don't make any mistakes in your head. Okay, so you can also multiply a rational fraction by a polynomial. You did stuff like this similar when you were younger, and you would do like a fraction, like 2/3 times a whole number. And if you remember what you would do there, you would just put it over a 1. Same thing here, we're just going to put this over a 1, and now it's a fraction, and you're going to treat it the exact same way. So we're still going to just reduce all the parts, see if we can simplify, and then do our multiplying. So let's look at this numerator, 2x minus 14. I can take a greatest common factor of a 2 out, which leaves me with x minus 7. And then for 4x subtract 6, we can take a 2 out of that as well, which leaves us with 2x minus 3. So already we can see those 2's cancel. And then on this polynomial, we do have that number in front of the x squared. So we need to do our factor by grouping. So the first step for factor by grouping is you times the first by the last number. So 6 times 6 is 36. And then we think what multiplies to be 36 but adds to be negative 13. So think of your factors there of 36. So let's do 9 times 4. 9 times 4 is 36, but we do need to get a negative 13. So if we make both of those negative, when we multiply them, they still turn to be positive, but the two negatives will make that negative 13. So if you remember with your factor by grouping, what we do is we keep the first and last terms, but we're rewriting this negative 13x as a negative 9x and a negative 4x. So I have the 6x squared still at the front, then the minus 9x, then the minus 4x, and then keep your plus 6. And we do that so that we have 4 terms now, so I can group it into 2 groups of 2, and we can do our greatest common factor from each group. So for 6x squared and 9x, we can take a 3x out of each. 6x squared divided by 3x is 2x. 9x divided by 3x is 3. And then on this one, make sure you bring that negative there, you don't forget it. But for negative 4x plus 6, we don't like this to be negative, so we're going to take out a negative 2, which will change both of these signs so that we have a positive 2x, and then 6 divided by negative 2 is negative 3. And that way our signs match inside of these. And remember, that's kind of your check to make sure you did it right. These two groups should match. So they're both a 2x minus 3, so that means I did it right. So to write my answer, I take one of the matching parts. I'm going to take the 2x minus 3. And then the two greatest common factors are going to go into their own binomial, so 3x minus 2. So now that's our factored form that's going to replace this polynomial. So I have a 2x minus 3 and a 3x minus 2. And again, it's just over a 1, which doesn't really do much. But we can see here now that the 2x minus 3 on the bottom will cancel with that one on the top. So everything canceled on the bottom except the 1, which again doesn't really do anything. So we're just going to keep this x minus 7 times this 3x minus 2. And now we can go ahead and multiply. So we get x times 3x is 3x squared. We get a minus 2x. And then negative 7 times 3x is a negative 21x. And then negative 7 times negative 2 is a positive 14. But we have these like terms here that we can combine. So negative 2 subtract 21 is a negative 23x. So our answer would be 3x squared minus 23x plus 14. And there's your answer. So let's just do one more of those, just for sake of time. So again, whenever you have a polynomial, just put it over a 1. And then we can start reducing each of our fraction parts. So h minus 1, we can't take anything out, so that'll stay the same. But 6h plus 3, we can take a greatest common factor of 3 out, which gives us 2h plus 1. Don't forget that 1 there. 3 divided by 3 is 1. Sometimes I see students just leave it off. And then we have another factor by grouping, since we have that 2h squared. So first you times those two numbers. 2 times 4 is 8. And then you think what multiplies to be 8 but adds to be 9. That's pretty easy. We're going to do 8 and 1. So now we just rewrite our trinomial to have 4 terms by doing 2h squared. And then we're going to do an 8h and a 1h, and then keep the plus 4 in the back. And now we can do our two groups of 2 and factor out our common factor. So for 2h squared and 8h, we can take out a 2 and an h, which 2h squared divided by 2h is h, and 8h divided by 2h is 4. And then for h plus 4, they don't have anything in common. So when that happens, your greatest common factor is just a 1. We do need that 1 though, so don't forget the 1 right there. So the reason we want that 1 is because the h plus 4 is going to be your common group. But when we go and write our second binomial, we're going to take the 2h, and I need something to go in this spot. So that 1 we can't forget, and we need to bring it down. And so h plus 4 times 2h plus 1 is going to replace this trinomial for the factored form, all over a 1. And so we see the 2h plus 1 here will cancel this 2h plus 1. And then I think that's all that cancels. So on the top we have an h minus 1 times an h plus 4. And on the bottom we have 3 times 1, which is just 3. And then again, you could sometimes just leave it in this form, but if they want you to FOIL it, you can go ahead and FOIL it really quick. That will give us h squared plus 4h minus 1h, which is 3h, and then negative 1 times 4 is a negative 4 all over 3. And that would be your answer. Okay. So that's multiplying. But let's get on to dividing. If you remember back to when you divided with number fractions, let's say you had a over b divided by c over d, you could just change it into a multiplying problem by doing the little saying keep, switch, flip. So you're going to keep the first fraction, change it to a multiply, and then you're going to flip the reciprocal of the second fraction. So we get d over c. So essentially what you're doing is you're just timesing by the reciprocal. So that's the fancy word that we use. And I use the little saying keep, switch, flip. See if I can write. So keep, switch, flip. So you keep the first fraction, switch it to a multiply, and flip it to the reciprocal. And then it just turns into a multiply problem, which we've been doing. So we're going to keep the first fraction, x over x plus y, change it or switch it to a multiply, and then you're going to flip this guy upside down so that the x plus y goes on the top and the xy goes on the bottom. And then if you could, you would reduce. All of these are actually already reduced. And we can see right away that this x plus y group cancels with this x plus y. And this x can cancel with that x. So if everything cancels on the top, remember it's like there's still a 1 there. We need to keep that 1. And then on the bottom we have a y. So our answer is 1 over y. Okay, that was kind of an easier one because we didn't have to reduce it all. Let's look at this one. So we're still going to keep the 4x plus 8, or 4k plus 8, over 6k minus 10. Change it to a multiply, and then flip this one upside down. So 9k minus 15 is on the top, and k squared plus 6k plus 8 is on the bottom. So now we've just changed it to a multiply problem, and we do the same thing where we just are going to reduce and factor each of the parts and see what can cancel. So for 4k plus 8, we can take a 2 out, which leaves us with 2k. Sorry, not a 2. Let's take a 4 out. Let's see if I can even think today. So we're left with k plus 2. That's better. And then on the bottom, 6k minus 10, we can take a 2 out, which leaves us with 3k minus 5. And then for 9k minus 15, we can take a 3 out, and that leaves us with 3k minus 5. And then we have k squared plus 6k plus 8, so this is one of our easier trinomials. We can just look and think what multiplies to be 8 and adds to be 6. That's going to be 2 and 4. So we're left with k plus 2 and k plus 4. So let's cancel what we can. This k plus 2 group can cancel with this one. And this 3k minus 5 cancels here. And then we can also reduce the 4 halves to be 2 over 1. And so now taking all of the parts left over, we have 2 times 3 in the top, which is 6. And then we canceled all of the variables out. And then the bottom, these are all canceled except for k plus 4. And just a reminder, you can't cancel the 6 and the 4. This k plus 4 is a group. It has to stay together, so it's all or nothing. So that's just going to be your answer since we can't cancel the whole group. So that is your dividing. Let's do one more. Let's do the harder one. This one's a little easier. So let's do this one. I'm just going to rewrite the problem to be a multiplication problem by doing keep, switch, flip. So keep the first fraction the same. Switch it to a multiply, and then we're going to flip this one upside down. So the 2x plus 4 goes to the top, and the x plus 4 goes to the bottom. And then we're going to reduce our fractions. So looking at this trinomial, again, the numbers that multiply to be 8 but add to be 6 are 2 and 4. So we can factor this to be x plus 2, x plus 4 on the top. And then for this trinomial, what multiplies to be -2 and adds to be 1 would be 2 and -1. So we're going to have an x plus 2 and an x subtract 1. So you can already see those are going to cancel. Let's come over to this one. For 2x plus 4, we can take a 2 out, which leaves us with x plus 2. And then we have the x plus 4, which doesn't have anything in common, so we just keep it. So we have a lot that cancels on this one. This x plus 2 cancels here. This x plus 4 cancels here. We have an x minus 1, and this x plus 2, we can't cancel this one because it's already been used, so we just have to keep it. So we have all of this, and then this is our answer. So we have 2 times x plus 2 over x minus 1, and you could distribute that 2 through and give your answer as 2x plus 4 over x minus 1. And that would be it. So that would be how you do divisions. You just want to rewrite them into a multiplication problem by doing keep, switch, flip. And then, trying to see, this video is getting long already. Let's just do one of these sections. It's kind of like the multiplying section where you had a polynomial. You're going to do the same thing by putting a 1 under this in order to make it a fraction. And then once you have the fraction, you can do keep, switch, flip. So we're going to keep the z squared minus 2z plus 1 over z squared plus 2. And they always do z's and 2's together, so try and make your z's and 2's look different. But then change it to a multiply, and then this is going to flip upside down. So the 1 is actually going to go to the top, and the z minus 1 comes to the bottom. And then it's just like what we've been doing. So let's simplify and reduce. So for this trinomial, what multiplies to be 1 but adds to be a -2, we can do -1 and -1. So this will factor to be z minus 1, z minus 1. And then for z squared plus 2, there's no common factor, so we have to just leave it as z squared plus 2. And then on this one, we have our 1, which just stays a 1, and the z minus 1 can't factor either. But the z minus 1 can cancel with one of the ones over here. So now we can just multiply straight across. We have z minus 1 times 1, which is just z minus 1. And then the only thing left on the bottom is just the z squared plus 2. And again, you can't cancel the z's here. This group has to stay a group, and same with this. So it's all or nothing. So since this entire group doesn't match this entire group, we can't cancel. So this would just be your answer. Okay, so I think I'm only going to do one of those. If you really want to, feel free to pause the video and do those on your own, but we're going to move on. I want to show you some of these. So how many of you guys have a panic attack when you look at these problems? So these are meant to scare you. I see these on the ACT just as kind of a scare tactic, I think. What it's saying is you have a fraction on the top being divided by a fraction on the bottom. So it's just a scary way of writing it to kind of stack them like that. But essentially it's still just a division problem. So don't freak out when you see them. They're just trying to scare you, literally. This is the same as taking this fraction on top, 1 over q plus 4, and dividing it by the bottom, 2q squared over 2q plus 8. These are equivalent problems. This is just kind of one way to write it. That's just a scary way to look at it. But once you write it this way, it's exactly what we've been doing. So you're going to keep, switch, flip. So let's keep the 1 over q plus 4, change it to a multiply, and then this guy is going to flip upside down. So the 2q plus 8 is in the top, and the 2q squared is in the bottom. And then reduce each of the 4 parts. Well, 1 we can't change, Q plus 4 doesn't have anything in common. So let's come over to this one, 2q plus 8. We can take a 2 out, which leaves us with q plus 4, which is convenient. And then we have the 2, I'm going to just write it as 2 times q squared, because then we can think of these 2's canceling, and these q plus 4's cancel. So all we're left with in the top is the 1, and then in the bottom we're left with a q squared. So really, it's not that bad, right? It's just a scary way of looking at it. So whenever you see them stacking these fractions like this, just take the top fraction and divide it by that bottom fraction. And it's really just trying to scare you. So like, look at that number 12. That one looks really intimidating, but I promise it's really not that bad. So you would just keep the top one, c plus 4 over c squared plus 5c plus 6. And then you're going to divide it by the bottom fraction. So think of this as a group being divided by this group. 3c squared plus 12c over 2c squared plus 5c minus 3. So then you would keep c plus 4, c squared plus 5c plus 6, change it to a multiply, and then flip this guy upside down so that the 2c squared plus 5c minus 3 is on the top, over 3c squared plus 12c in the bottom. And then it's just like what we've been practicing. So you would go through and reduce and then cancel. But for sake of time, I'm not going to finish that one. Just don't be afraid of them. You won't see them very often, but again, I do see them on the ACT, and I really think it's just a problem to try and trick kids or scare them so that they don't want to do it. But you guys will know how to do it, so don't skip it. So just keep switch flip and you'll be fine. So go ahead and get started on the homework. It's just 2.2, and then if you have any questions, please feel free to email me. We can set up a Zoom time and work together. I'm here to help you. But hope you guys have a good day. See you later. Bye.